National Electrical Code, specifically Article 800.76, addresses the separation of power and communication cables. This section states that power cables and communication cables shall not occupy the same compartment, duct, outdoor enclosure, raceway, or cable tray. However, there are exceptions to this rule. Exception number 1 states that where it is found to be impracticable to avoid occupying the same raceway, conduit, or cable tray, then the communication cable shall be permitted to occupy a separate compartment within the enclosure or raceway, or a different raceway or cable tray shall be used. Exception number 2 states that where power and communications occupy the same trench, the cables may be installed in the same conduit, provided that the cables are separated by a minimum distance of 3 inches or 76 millimeters and any exposed section of the power cable carries 60 volts or less. In addition to the National Electrical Code, IEEE Standard 142-1991, also known as the Green Book, provides further guidance. This standard recommends that power and communication cables should be installed in separate ducts or trenches if possible. If installed in the same duct or trench, the separation between the cables should be at least 12 inches or 305 millimeters. It is important to note that local codes and regulations may have additional requirements or restrictions regarding the separation of power and communication cables. These local regulations should always be consulted and followed to ensure compliance and safety. Considering the National Electrical Code, specifically Article 800.76, it's crucial to understand its implications for cable installations. The primary directive is to prevent power cables and communication cables from sharing the same confined space. This includes compartments, ducts, outdoor enclosures, raceways, and cable trays. The rationale behind this separation is to minimize the risk of interference, electrical hazards, and potential damage to sensitive communication equipment. The NEC recognizes that strict adherence to this separation rule might not always be feasible in every situation. This is where exception number 1 comes into play. It acknowledges the practical challenges that installers may face and provides an alternative solution. If it's deemed impracticable to maintain complete separation, the exception permits the use of the same raceway, conduit, or cable tray, provided that the communication cables are housed in a separate compartment within the enclosure or raceway. Alternatively, the installer can opt for a different raceway or cable tray altogether for the communication cables. Exception number 2 addresses scenarios where power and communication cables are located within the same trench. In such cases, the cables can be installed in the same conduit, but with specific conditions. Firstly, a minimum separation distance of 3 inches or 76 millimeters must be maintained between the cables. Secondly, an exposed section of the power cable must carry 60 volts or less. This voltage limitation is crucial to minimize the risk of electrical shock and interference with the communication cables. IEEE Standard 142-1991, the Green Book, offers additional recommendations for cable installations, particularly in industrial and commercial settings. It reinforces the importance of separating power and communication cables whenever possible. The Green Book suggests that power and communication cables should ideally be installed in separate ducts or trenches. This approach provides the best level of protection against interference, noise, and potential hazards. However, if it's necessary to install the cables in the same duct or trench, the Green Book recommends a minimum separation distance of 12 inches or 305 millimeters. This greater separation distance, compared to the NEC exception, provides an extra margin of safety and reduces the likelihood of electromagnetic interference. In addition to the NEC and IEEE standards, local codes and regulations should always be considered. These local regulations may impose additional requirements or restrictions on cable installations. It's essential to consult with the relevant local authorities or electrical inspectors to ensure compliance with all applicable codes and regulations. Failure to comply with these regulations can result in penalties, delays, and potential safety hazards. When dealing with power cables and communication cables and duct banks, several key considerations come into play to ensure safety, performance, and compliance with relevant codes and standards. Firstly, understanding the purpose and voltage levels of the power cables is paramount. Determine whether they are low voltage, medium voltage, or high voltage cables, as this will significantly impact separation requirements and safety precautions. Secondly, identify the type of communication cables involved, whether they are coaxial cables, twisted pair cables, fiber optic cables, or other types. Different communication cables have varying sensitivities to electromagnetic interference, which will influence separation considerations. Thirdly, thoroughly review the National Electrical Code, specifically Article 800.76, and understand the general prohibition against power and communication cables sharing the same space, as well as the exceptions that permit such co-location under specific conditions. Fourthly, assess the feasibility of maintaining complete separation between power and communication cables. If it's deemed impracticable, carefully consider the options provided in exception number 1, such as using separate compartments within the same raceway or cable tray. Fifthly, if the cables must occupy the same trench, ensure compliance with exception number 2, maintaining a minimum separation distance of 3 inches or 76 mm and ensuring that any exposed section of the power cable carries 60 volts or less. Sixthly, refer to IEEE Standard 142-1991, the Green Book, for additional guidance, particularly the recommendation of at least 12 inches or 305 mm separation when cables are installed in the same duct or trench. Seventhly, always consult local codes and regulations, as they may have more stringent requirements than the NEC or IEEE standards. Eighthly, implement proper grounding and bonding techniques to minimize the risk of electrical hazards and electromagnetic interference. Ninthly, use appropriate cable management practices to ensure that cables are neatly organized and supported, reducing the risk of damage or strain. Tenthly, conduct thorough inspections and testing to verify that the installation meets all applicable codes, standards, and safety requirements. Regarding the specific situation of power cables and coaxial communication cables in the same duct bank, with both cables in their own conduit, the NEC provides some flexibility. Even though the cables are in separate conduits, the general rule of Article 800.76 still applies, prohibiting them from occupying the same duct. However, the exceptions offer potential solutions. If it is deemed impracticable to use separate ducts, exception number 1 could be invoked, allowing the communication cable to occupy a separate compartment within the duct. Alternatively, if the power cable carries 60 volts or less, exception number 2 could be applied, provided that a minimum separation of 3 inches is maintained. In addition to these NEC provisions, the IEEE Green Book recommends a 12-inch separation, which could be a valuable guideline to follow, even if not strictly mandated by code. Furthermore, local codes and regulations should be consulted to ensure full compliance. In the state of Colorado, electrical installations are governed by the Colorado Electrical Code, which is based on the National Electrical Code with some state-specific amendments. It is crucial to consult the latest version of the Colorado Electrical Code and any relevant local ordinances to ensure compliance with all applicable requirements. Local electrical inspectors can also provide valuable guidance and clarification on specific code interpretations. When installing power and communication cables in duct banks, consider the potential for electromagnetic interference. Power cables can generate electromagnetic fields that can interfere with the signals carried by communication cables, leading to degraded performance or even complete signal loss. To mitigate this risk, consider using shielded communication cables or installing the cables in grounded metal conduits. Proper grounding and bonding techniques can also help to reduce electromagnetic interference. In addition to electromagnetic interference, consider the potential for physical damage to the cables. Duct banks can be subject to physical stress from soil movement, vibrations, and other factors. To protect the cables, use rigid conduits and ensure that the cables are properly supported and secured within the conduits. Also, consider the environmental conditions within the duct bank. Duct banks can be subject to moisture, temperature variations, and exposure to chemicals. Use cables that are rated for the specific environmental conditions and ensure that the conduits are properly sealed to prevent moisture from entering. Proper labeling of cables and conduits is essential for future maintenance and troubleshooting. Clearly label all cables and conduits with their voltage, function, and destination. This will help to prevent accidental damage or misconnections during future work. When working with power cables, always follow safe work practices. To energize the power cables before working on them and use appropriate personal protective equipment such as gloves and eye protection. Also, be aware of the potential for arc flash and take appropriate precautions to prevent injury. Regular inspections and maintenance of duct banks are essential to ensure their continued safety and reliability. Inspect the duct banks for signs of damage such as cracks, leaks, or corrosion. Also, inspect the cables and conduits for signs of wear or damage. Repair any damage promptly to prevent further deterioration. When making repairs or modifications to duct banks, always follow the same codes, standards, and safe work practices that were used during the original installation. This will help to ensure that the duct banks continue to operate safely and reliably. The National Electrical Code serves as a foundational standard for electrical installations, but it's essential to recognize that local jurisdictions often have the authority to adopt, modify, or supplement the NEC to address specific local conditions and concerns. These local amendments can be more stringent than the NEC, reflecting unique environmental factors, population density, or other regional considerations. Therefore, relying solely on the NEC without considering local codes can lead to non-compliance and potential safety hazards. To ensure adherence to all applicable regulations, it's crucial to consult with local electrical inspectors or the relevant authorities responsible for enforcing electrical codes in this specific geographic area. They can provide valuable insights into local amendments, interpretations, and any specific requirements that may deviate from the NEC. This proactive approach helps to avoid costly rework, delays, and potential liabilities associated with code violations. IEEE Standard 142, known as the Green Book, offers a comprehensive guide to grounding and bonding practices for electrical power systems. While not a mandatory code, it provides valuable recommendations and best practices for ensuring the safe and reliable operation of electrical systems. The Green Book emphasizes the importance of establishing a lower impedance ground path to facilitate the rapid clearing of ground faults, thereby minimizing the risk of electrical shock and equipment damage. It also addresses the mitigation of electromagnetic interference and the reduction of noise in sensitive electronic equipment. Adhering to the recommendations outlined in the Green Book can significantly enhance the overall safety and performance of electrical installations. When power and communication cables run in close proximity, electromagnetic interference becomes a significant concern. Power cables, especially those carrying high current, can generate electromagnetic fields that can induce unwanted signals in nearby communication cables. This interference can degrade the quality of communication signals, leading to data errors, reduced bandwidth, and even complete signal loss. To mitigate electromagnetic interference, several strategies can be employed. Firstly, using shielded communication cables can help to block electromagnetic fields from reaching the conductors. Secondly, installing cables and grounded metal conduits provides an additional layer of shielding and helps to dissipate electromagnetic energy. Thirdly, maintaining adequate separation between power and communication cables, as recommended by the NEC and IEEE standards, reduces the strength of the electromagnetic field at the location of the communication cables. Fourthly, employing proper grounding and bonding techniques ensures that electromagnetic energy is safely diverted to ground. In summary, when dealing with power and communication cables and duct banks, a multifaceted approach is essential. This includes adherence to the National Electrical Code, consideration of IEEE standards, compliance with local codes and regulations, and the implementation of best practices for grounding, bonding, and electromagnetic interference mitigation. By carefully considering these factors, installers can ensure the safety, reliability, and performance of electrical and communication systems.